The B-52 Stratofortress is an iconic symbol of U.S. strategic air power. Introduced in the early 1950s, it was designed as a long-range, subsonic jet capable of carrying nuclear or conventional weapons anywhere in the world. Its massive wingspan, 8 engines, and robust airframe allow it to fly missions exceeding 8,000 miles without refueling. The B-52 was not used during WW2, it was conceptualized in response to Cold War threats, but its design reflects lessons learned from previous conflicts. Its presence alone serves as a deterrent, a silent warning of U.S. air supremacy. Crews train rigorously for high-alert scenarios, often simulating global nuclear strikes. The aircraft's versatility is unmatched, performing reconnaissance, strategic bombing, and even maritime operations. Every mission relies on precision, discipline, and coordination between aircrew and ground command. Despite its age, modernized avionics and weapon systems keep it relevant in contemporary warfare. It embodies the principle that deterrence often depends on capability, readiness, and psychological impact. The B-52's development began in the late 1940s under Boeing's guidance. Engineers aimed to produce a bomber that could outmatch any potential threat, including the Soviet Union's air defenses. Its design prioritized high-altitude performance, long-range endurance, and payload versatility. The 8 turbojet engines, arranged in 4 twin pods under the wings, provide both reliability and sheer thrust. Innovations like swept wings and reinforced fuselage allowed the bomber to carry unprecedented payloads. The aircraft's navigation and bombing systems were revolutionary for their time, incorporating radar-assisted targeting and early electronic countermeasures. Pilots had to master both manual and automated controls, balancing long-duration flights with precise mission execution. Each crew member's role, from pilot to navigator to tail gunner, was critical for operational success. Early tests pushed the aircraft to its limits, revealing both strengths and areas needing refinement. By the early 1950s, the first B-52s entered service, heralding a new era in strategic aviation. The B-52's ability to carry massive payloads makes it a formidable weapon. Standard missions could involve up to 70,000 pounds of bombs, including nuclear, conventional, and precision-guided munitions. Its bomb bays are enormous, spanning much of the fuselage, designed for both flexibility and rapid deployment. Ground crews practice loading drills with clockwork precision, understanding that mission success relied on both speed and accuracy. Despite its size, the aircraft maintains impressive maneuverability at high altitude. This allows it to avoid threats and position itself optimally for attacks. For decades, the B-52 has been the backbone of U.S. strategic deterrence. Pilots are trained to handle adverse weather, electronic countermeasures, and enemy interception attempts. Exercises simulate scenarios ranging from Cold War nuclear strikes to humanitarian support. The aircraft's versatility ensures it remains relevant despite newer jets and changing warfare strategies. Its endurance emphasizes that air power is not just about speed, but sustained presence. The interior of the B-52 is a complex, highly coordinated environment. Pilots operate alongside navigators, bombardiers, electronic warfare officers, and flight engineers. Each station is equipped with specialized instruments, radar screens, and communication devices. The cockpit layout emphasizes efficiency and situational awareness. Crews undergo months of training to master these systems, simulating high-pressure missions. Missions often last more than 12 hours, requiring careful crew rotation, resource management, and psychological resilience. The tail gunner position, though later removed in modern versions, was historically vital for rear defense. Communications with ground command and other aircraft are constant, ensuring mission objectives are achieved safely. Every movement inside the cabin has a purpose, from monitoring fuel to adjusting bomb bay mechanisms. The coordination between human skill and machine capability demonstrates why the B-52 became a symbol of precision and reliability. Its interior is a living example of teamwork under pressure. Long-range missions are the B-52's specialty. The bomber can fly halfway around the globe without refueling, thanks to its enormous fuel capacity and efficient engines. In-flight refueling extends its reach even further, allowing near unlimited operational flexibility. Mission planning involves careful consideration of weather, enemy defenses, and strategic targets. Pilots rely on advanced navigation systems, including inertial and radar guidance. Flight formations are planned to optimize fuel efficiency and defensive positioning. During high-alert situations, the B-52 can be scrambled within hours, projecting power rapidly. This capability makes it a key asset in both deterrence and active conflict scenarios. The ability to stay airborne for extended periods also allows continuous monitoring of hostile regions. Endurance flights test both machine and crew, proving the aircraft's reliability under pressure. Strategic presence in the sky often deters conflict before it even begins. The B-52's design has endured because of its adaptability. Over decades, it has been upgraded with advanced avionics, radar, communication systems, and precision weapons. Modernized versions can carry smart bombs, cruise missiles, and even electronic warfare payloads. This ensures the aircraft remains relevant in contemporary conflicts, despite being designed during the early jet age. Engineers retrofit aging airframes with the latest technology while preserving the bomber's structural integrity. The aircraft's size allows for significant upgrades without compromising performance. Its durability is legendary. B-52s have been in continuous service for over 70 years. Crew training evolves alongside technological upgrades, ensuring operational efficiency. Maintenance schedules are rigorous, focusing on engine performance, hydraulic systems, and avionics reliability. Each update reflects lessons learned from decades of strategic operations. The B-52 exemplifies how a well-designed platform can remain effective across generations. High alert readiness is a defining feature of the B-52 program. Crews and aircraft are kept in a state of constant preparedness for rapid deployment. Alert hangars are equipped with refueling systems, munitions, and maintenance teams on standby. Pilots can scramble at a moment's notice, simulating nuclear strike or high-priority bombing missions. This level of readiness reflects Cold War tensions, where seconds could determine global outcomes. Drills test every aspect of crew coordination, from takeoff to navigation to weapon deployment. Psychological resilience is as important as technical skill, as the pressure of immediate response is immense. Historical documents show that alert crews maintained high morale despite extended wait times. The B-52's readiness demonstrates the strategic philosophy of deterrence, showing capability to act decisively prevents conflict. High alert exercises also serve as training for unforeseen crises. The B-52 has played a role in numerous historical operations. Though not a World War II aircraft, its missions during Vietnam, the Gulf War, and beyond illustrate its strategic importance. Carpet bombing missions, precision strikes, and reconnaissance operations leveraged its payload capacity and endurance. Pilots navigated hostile skies, often under heavy anti-aircraft fire, demonstrating the aircraft's resilience. The bomber's ability to carry diverse weapons made it adaptable to changing combat strategies. Crews relied on meticulous planning, intelligence, and coordination with ground forces. Its psychological impact on adversaries was significant, often shaping military decisions without direct engagement. Each mission added to the aircraft's legendary status in U.S. Air Force history. The B-52 became synonymous with strategic dominance and operational flexibility. Lessons learned from these missions continue to influence bomber tactics today. The aircraft's subsonic speed is complemented by its altitude capabilities. Flying at 50,000 feet, it can evade many surface-to-air defenses, while radar and countermeasure systems enhance survivability. High-altitude flight reduces fuel consumption and improves sensor effectiveness. Crews monitor complex navigation, weather, and threat systems constantly. Missions are planned to maximize altitude advantages while ensuring precise payload delivery. The B-52's design allows for both stealthy approach and overt presence. Its range enables operations over hostile territory without immediate support. Historical data shows that altitude often made the difference between mission success and failure. These flights require endurance, skill, and coordination under constantly changing conditions. The aircraft's ability to combine high altitude with long-range capability is central to its strategic role. Crew safety and survivability have always been priorities. The B-52 incorporates multiple redundancies in engines, hydraulics, and flight controls. Escape protocols, parachutes, and survival kits are standard for all personnel. Simulated emergency drills train crews for engine failure, fire, or hostile engagement. Redundant navigation and communication systems ensure continuity under attack. The aircraft's structural strength allows it to sustain damage without catastrophic failure. Historical accounts describe crews returning safely from missions after sustaining heavy fire. Training emphasizes quick decision-making and calm under pressure. Crew cohesion is vital for surviving long-duration flights. The B-52's design philosophy balances offensive power with crew protection. This combination contributes to its legendary reliability. The bomber's engines are engineering marvels. Each pod houses 2 turbojets, designed for maximum thrust and fuel efficiency. Engine maintenance is rigorous, ensuring operational reliability. Mechanics monitor turbines, exhaust systems, and fuel lines with precision. The B-52 can fly with 1 or more engines offline, a testament to its redundancy. During long missions, engine monitoring is continuous, with flight engineers adjusting performance for optimal fuel consumption. The roar of 8 engines creates a powerful auditory signature, both intimidating and awe-inspiring. Early engines were upgraded to turbofans in modern versions, reducing noise and improving efficiency. The combination of thrust, endurance, and reliability makes the aircraft capable of sustained global operations. Engineers' meticulous care preserves performance across decades. Electronic warfare and countermeasures are integral to B-52 missions. Jamming systems, radar decoys, and communication encryption protect the aircraft from detection. Crews train extensively in electronic counter strategies, simulating hostile radar and missile threats. Mission planning involves both offensive and defensive electronic tactics. The aircraft can carry electronic pods to disrupt enemy communications and tracking. Technological upgrades over decades have enhanced these capabilities, ensuring the B-52 remains resilient in modern warfare. Pilots coordinate with ground command and escort aircraft for complex electronic operations. Historical exercises demonstrate that electronic warfare often determines mission survivability. The combination of human skill and technology amplifies strategic effectiveness. Countermeasure readiness is a key factor in the aircraft's enduring relevance. Training for long-range, high-alert missions is grueling. Crews spend months mastering navigation, bombing, and emergency protocols. Simulated missions replicate high-stakes scenarios, including nuclear strike exercises. Pilots must maintain focus for extended periods while monitoring multiple systems. Physical endurance and mental resilience are critical. Crew rotations are carefully managed to ensure alert readiness. Historical records highlight the intense preparation required before a single sortie. Coordination between all crew members ensures mission success. Exercises also incorporate maintenance teams, refueling, and ordnance handling. The rigorous training demonstrates that strategic power relies as much on human skill as on aircraft capability. The psychological impact of the B-52 cannot be understated. Its mere presence signals deterrence and overwhelming capability. Adversaries are aware that the bomber can deliver devastating payloads globally. Its visibility in strategic regions serves as a constant reminder of U.S. air power. Crews understand that mission success often influences global diplomacy and security. Exercises in high-alert scenarios build both confidence and responsibility. The aircraft's endurance, payload, and readiness amplify its deterrent value. Historical instances show that the threat of deployment alone prevented escalation. The B-52 remains an icon of strategic calculation, power projection, and psychological influence in military doctrine. Today, the B-52 Stratofortress continues to serve as a cornerstone of U.S. strategic air power. Despite being designed over 70 years ago, it remains fully operational, due to constant upgrades, rigorous maintenance, and crew training. Its legacy combines technological innovation, human skill, and psychological impact. The aircraft demonstrates how endurance, versatility, and preparedness define strategic bombing capabilities. High-alert missions, long-range endurance, and payload flexibility ensure that it will remain relevant for decades. Pilots and crews continue to embody the precision, discipline, and resilience that have defined the B-52 since its inception. Its history, missions, and continued presence remind us that strategic deterrence relies on readiness, reliability, and global reach. The B-52 is more than a bomber. It is an enduring symbol of strategic air power.